Assalamualaikum warahmatullahi wabarakatuh to Dr. Camelia and Dr. Yoshide Yamada. So today I would like to introduce myself. My name is Ahmad Qamarul Hakmani Bin Samsol from Section 1 to present about analog and digital modulation techniques for subject communication electronics. So the first thing, communication systems are essential in modern life to enabling radio, television, mobile networks such as on our devices, networks, and internet. At the heart of these systems is modulation, so which allows information signals to travel uh, efficiently over long distance. So I would like to present about this, explain more to analog and digital modulation techniques and their circuits and key differences. So what is modulation? Modulation is the process of varying a high frequency carrier signal according to a low frequency message signal. This improves transmission efficiency, reduce antenna size, and increases resistance to noise. Demodulation, on the other side, at the receiver recovers the original information. So this is the diagram for the message carrier, then modulated signal. So the next one is we talk about the analog modulation, AM. So on other name is the amplitude modulation. Is one of the earliest modulation techniques. In amplitude modulation, the carrier's amplitude changes according to the message signal while its frequency stay constant. The message information stays appears in the waveform envelope. So we moves out to the next AM modulator and demodulator. So the AM modulator use a non-linear transistor to combine the carrier and message signals. A band pass filter removes the unwanted frequencies at the receiver. An envelope detector use a diode and RC circuit to recover the original message signal. So we will talk about the frequency modulation. Frequency modulation. The carrier frequency varies with the message signal while the amplitude remains constant. FM or frequency modulation offers better noise immunity and is widely used in high quality radio broadcasting and two-way communication. So for example, like televisions that nowadays using Astro or Enjoy or etc. So digital modulation, the second modulation for today, is the first divided to two. So the first thing is we touch about the amplitude shift keying or ASK. ASK is the simplest digital modulation technique. The carrier signal is transmitted when the data bit is 1 and suppressed when the bit is 0. ASK is simple but sensitive to noise. So as for example, this is the diagram for the ASK. It says that the starting from binary data 1010 data waveform and it change to the amplitude signal waveform. So as for the ASK also have demodulation and their application. So the first thing is the demodulator, which is the envelope detector and comparator decision circuit. So it used a envelope detector, the famous one, followed by a comparator to decide between binary 1 and 0. ASK is commonly used in RFID systems, optical links, and remote control devices. So it's like any devices that needs a remoted or RFID in the toll barrier in highway, as for example. So next one we will touch about the second one, phase shift keying or PSK. So in PSK, information is encoded by changing the phase of the carrier's signal. Binary PSK use two phases separating by 180 degrees. PSK requires coherent detection but provides excellent noise confirmation. So as for example, this is the coherent detection circuit or block diagram you can see. So the next one, we want to lock in about the comparison. So the first thing, the analog modulation use a simpler circuits, but it's more affected by noise. Digital modulation provides higher bandwidth, efficiency, and better reliability, making it suitable for modern communication systems. So as for the conclusion for the presentation today, modulation is a fundamental to communication systems mainly, while analog modulation remains useful in specific application, but digital modulation dominates the modern technologies due to efficiency and robustness. So that's all from me. Thank you very much.